In this video, we're going to talk about collections in Python. So you recall our diagram of Python's built-in data types. We've already covered the left-hand side of this diagram, consisting of the scalars or the individual items, such as an individual integer or float. Now we're going to talk about collections or groups of items, or collections of so-called objects. Now, I use this term objects because it has a specific definition in computer science. It relates to the idea of object-oriented programming, which you may be familiar with. We're not going to cover object-oriented programming here, but it is still important for you to understand what an object is. So let's talk about that before getting into the collections. An object roughly consists of data and methods. And it's important to note that everything in Python is an object. Now, this is not true of every computer programming language, but it is true of Python. Everything in Python is an object, including, say, all of the scalars, and also all of the functions in Python are objects, as well as all of the collections. So what does that mean? That means that if you have, say, a scalar a with value 2, well, that 2 is its data of the object a, but there may also be methods attached to the object a. I'll take a quick moment to demonstrate this in Jupyter. Here I've defined a variable a and given it the value 3, so it's an integer. B is 4.3, so it's a float. And C is the string hi there. So each of these are objects, so we know that they may have methods attached. And if you want to list those methods, we use the built-in called dir. So we pass C, for example, the string into dir, and that lists all of the methods that are attached to that object. We see here that many of those methods begin with and end with this double underscore symbol. And what that means is that those methods are reserved for Python's internal use. So you can ignore them. The methods that are for users come later. Those begin with capitalize, centerfold, format, etc., 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 down to upper and zfill. So how can we call these methods that are attached to C? Well, to do that, we use C, we write C, and then a period, and then the name of the method. And then if it requires some arguments, we pass them in through parentheses. In this case, upper takes no arguments. So run this, and it returns a new string that is our original string hi there, but capitalized. Okay, that's what upper does. Now, Jupyter also includes a nice autocomplete functionality where you press period and then tab, and it opens up this little window that lists all of the methods that are attached to C, or the string. And then we can just click on upper and call it that way. All right, back to the slides. So everything in Python is an object. Now, the true power of this comes with the next statement, that all objects in Python are first class. This means that they can be passed into functions and also stored in collections. So passed into functions. We saw before that integers, floats, booleans, etc. could be passed as arguments into a function. And what we're saying now is that anything can be passed as an argument into a function. That includes collections, but it also includes functions. We can pass a function into another function. This opens the door to the so-called functional programming, which is very useful and we'll touch upon later. Objects can also be stored in collections. So that means that even collections can be stored within collections, and also you can make a collection of functions. So we've established what objects are. Everything in Python is an object. Let's get back to collections and go over the different types of collections that exist. This table illustrates the different types of collections that we have available in Python. So let's begin with the most basic type of collection, which is the set. A set in Python is similar to a set in mathematics. That is, it is a collection, an unordered collection of unique objects. And I'm illustrating that here, where each object is an icon. To create a set, we use the open close brackets symbol. As I said, a set is not ordered, but it is also mutable. So I'll describe what that means a little bit later. For now, I'd like to just demonstrate sets in a Jupyter Notebook. So let's create a set. We're going to call it A. And in that set, I'm going to put a string called wow, then an integer and a float. Okay, that set has 3 items. To get the number of items from any collection, be it a set, a list, a tuple, etc., we use the built-in len. So that tells us that there are 3 items in that set. What methods are available for sets? Here they are. We have, for example, add, that is to add an item to a set, clear, to remove all items from sets. Some other good ones, intersection and union. Those are the basic operations that one does on sets. One can also take a difference between 2 sets. Okay, let's try that out. So B, let's call it another set. That's going to be, let's have the same string wow, but now a different number. Okay, so now let's take the intersection of those 2 sets. So I'm going to call intersection on B and pass in A. That's just the intersection of A and B, and it gives us wow. Wow, the string wow, is the only element that is common to both sets. How about the union? The union of the sets has the 3 numbers and then only 1 copy of the string wow. That is because a set can only have a unique copy of every item. So just to stress that point, what if we made a set C and we put in a 5 and then we put in some more 5s? What is that going to look like? Well, C is only going to have 1 copy of the number 5. All right, we're back at the table. So it's sometimes the case that a set is not exactly what you want, either because you're interested in preserving some sort of inherent order in the elements, or because you want to allow for repetition. In that case, a list may work better. So I'm showing a list here as a sequence, an ordered sequence of elements. And I'm also showing that the list allows for repetition. Lists are denoted with square brackets. As I just said, they're also ordered, and they are mutable. So it's time to talk about mutability. What do I mean by mutability? A list is mutable because you can add objects to it after it's created. And you can also delete items from a list after it's created. You can also modify elements within the list after it's created. In some rare cases, you do not want to allow for a list to be changed. And in that case, you would use a tuple. So a tuple is identical to a list, except that it does not allow for mutability. It is immutable. To create a tuple, instead of using square brackets, you use parentheses. So let's see this in action. Here I've defined a list called A, and it contains a string, wow, an integer 3, and a float 4.5. Then I defined a tuple, B, with the exact same content. So let's start by seeing what methods are available and attached to the tuple. What we see here is that there aren't many. There are only 2 methods, count and index. So count will count the number of times that an item is found in the tuple. So how many times is 0 found in this tuple? Oops, should be a period. 0 times. How about the number 3? It's there 1 time. Okay, let's see what methods are attached to a list. Okay, there are a few more. So we have count and index, but we have some others such as append, clear, copy, extend, insert, pop, remove, etc. So all of these other methods have to do with modifying the list, which we could not do with the tuple. So let's try append, and I append the string high, and we'll see what happens. So now we have A with the string high appended to it. And if I keep on executing this cell, it keeps on appending high. We could also remove the element high, and in this case, it will remove the first time it encounters high. And so now it removed high, and if I keep on doing this, it removes copies of the string high. The next collection data type are the strings. We've already encountered strings before, but the interesting thing to notice here is that strings are immutable. That means that once you create a string, you cannot modify it by, say, adding a letter or changing a letter or removing a letter. It's fixed. So you can think of a string kind of like a tuple where all of the elements are characters. Then finally, we have the dictionaries. And a dictionary is a mapping between two sets, kind of like a function in math. So for a dictionary, the domain set is called the keys, and these map to the set of values. We'll have a lot more to say about dictionaries in a future video. For now, I want you to notice that there are 3 ordered data types: the lists, the tuples, and the strings. And these collectively go under the name of the sequences. This will be the topic of our next video. I'll see you then.